Our next big topic is the Manic reaction. This is a reaction that actually contains 3 different components. You have to have formaldehyde and a secondary amine in order to do a Manic reaction. So in the Manic reaction, you have the initial reaction of the secondary amine with the aldehyde in order to form the hemiaminal, which then loses an equivalent of water to form an iminium ion. The iminium ion is a very good electrophile because you have this positive charge on the nitrogen. That means that by attacking what used to be the carbonyl carbon, we can push those electrons onto the nitrogen and eliminate that positive charge. So the potential for neutralizing the positive charge on the nitrogen makes the iminium carbon here highly electrophilic. So when the ketone is added and an enol is formed, it is going to attack that carbon, which pushes the electrons onto the nitrogen and satisfies the positive charge. And then you end up with what is called a manic base. So what this essentially does is adds on another carbon onto your ketone and also an amine. So you've made a compound that now contains both a ketone and an amine and has an extra carbon. So let's practice figuring out the product of a Manic reaction. So you have to remember that in your first step, the formaldehyde and the secondary amine are always going to react in that initial step. So the conditions for a Manic reaction are typically acid. But since conditions are not being specified here, let's just go ahead and pretend there's no acid present. So the secondary amine is going to attack the formaldehyde. So remember, theoretically, we haven't necessarily added this in yet, but also aldehydes are much more susceptible to addition anyway. So the amine is going to preferentially react with the aldehyde. So we have our intermediate here, and then your textbook does the thing that I don't like where it does an intramolecular proton transfer, but for the sake of saving a little space, let's just go ahead and do it. So at this point, the presence of acid becomes quite important because we are going to want to protonate that hydroxyl group. It can then be pushed out by the nitrogen's electrons. That's our iminium ion. So then in the next step, you have to use the enol that would form from acetophenone in acid to attack your iminium ion. So now the only thing left to do is to deprotonate our ketone to get our product.